Bismillahirrahmanirrahim. Dear students, आज हम स्टार्ट करेंगे another concise series, and highly concise, to the point. It will be highly useful for your theory exam and also for the competitive exams जो आप future में face करेंगे for maybe your for any lectureship exam or your PG entrance or NET, GATE and related exams. So today we'll start with your 3D transition series. In that 3D transition series, our topic will be the electronic configuration. So this is our topic today, that is the electronic configuration. तो बात करेंगे about the electronic configuration of 3D transition series. इसके अलावा there will be also a concise note. एक note होगा that you can use for the exam purpose. That will be available as a PDF and you can see the link in the description. So let's begin with our class. ये है हमारा आज का topic, to the point, talking about the electronic configuration of 3D transition series. We'll start. 3D transition series जो है, we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Now this is the atomic number, this is your symbol. Now ये column important है, electronic configuration. So it's actually argon. If we see with the first element, argon 3d1 4s2. Since it has 21 atomic number, that means the number of electrons is equal to number of protons. अगर आपका atom neutral है, so that means it has 21 electrons. Argon, we know it has atomic number 18. So you add 18 electrons plus 19 and these two, that is 21. ऐसे आप electronic configuration लिखते हैं इन elements का. Now, जो इसमें main चीज है, that is you move to chromium. Look at this chromium. So you expect the electronic configuration should be, you normally expect that it should be argon, then followed by 3d4 and 4s2. This is what normally you expect as per the trend, since we are adding 1 electrons each when you move from left to right. ठीक है? So लेकिन आप यहाँ देख रहे हो, it is 3d5 4s1. That means 1 electron has got shifted from 4s orbital to 3d. So this is number 1. Likely there's another important thing, that is in the copper. Now the copper, it is 3d10 4s1, but actually it would have been, as per the trend, it should be like this: argon followed by 3d9 and 4s2. But it is 3d10 4s1. That means 1 electron moves from 4s orbital to 3d9. Now this was about the electronic configuration of these elements. Fine. Now let's move about the point number 1. यहाँ पे कुछ points लिखे हुए हैं, to the point. 3D transition series, it starts from scandium, that is atomic number 21, to zinc, that is atomic number 30. So these elements, they lie in the 4th period. So point number 2 is that they lie in the 4th period. We know that जो आपका periodic table होता है, इसमें दो चीजें होती है. एक आपका period and group. Period means we starts from left to right. Let's say from left to right. This is period. And group means which starts from top to bottom. That is your group. अगर ये जो periods होते हैं, we know that there are periods in the periodic table. Now this follows in the 4th period. The transition series, that is 3D, it's present in the 4th period of the periodic table. ठीक है? Number 2. Number 3, in these all elements, the last electron, it goes to 3D orbital. यहाँ पे भी आप देख सकते हैं that last electron basically goes in the 3D. आप इस पूरी series में देख सकते हो, last electron enters in the 3D orbital. So that's why it's named as 3D transition series. So in this series, 3D orbitals are progressively filled up as we move from scandium to zinc. Now, talking about that exceptional case, it may be noted that the configuration of chromium and copper, they have the anomalous behavior. That is something which is against the trend. Since chromium has 5 electrons instead of 4, so हम यहाँ देखा था, it has 5 electrons in the 3D instead of 4 that was expected normally. Likely in copper it has 10 electrons instead of 9. Thus the correct configuration of these is argon 3D 5 4s1 instead of this, and likely argon 3D 10 4s1 instead of this. Now question is that why this electron has shifted from S to 3D, 4s to 3D in both the cases. Simple. जब हमने एक इलेक्ट्रॉन को ट्रांसफर किया, उसे क्या, we have achieved the half filled state here. It becomes 3D 5. We know that d orbit in the d subshell there are 5 orbitals, dxy, dyz, dzx, dx square minus y square and dz square. And one orbital can accommodate 2 electrons, so it can total accommodate 10. So अगर हम half filled condition देखेंगे, then there should be 5 electrons, and if it is completely, then it should be 10 electrons. And we know that जब भी आपका ये जो orbitals है किसी भी subshell में, if they achieve this half filled state or this completely filled state, it is considered to be highly stable. Now why is it so? Reason number 1, because the system becomes symmetrical. Reason number 2, when your system is partly filled or completely filled, the exchanges are more. Electrons exchange themselves. So what that results, that exchange, it actually results in lowering the energy of system due to the exchange energy. So number 1, due to the symmetry and due to the exchange energy, in the chromium and copper, we have anomalous behavior of electronic configuration. Fine. Now ये बहुत important question है. Let's move to the next point. We have complete and valence electronic configuration of the 3D elements can be written as. So हम कैसे इसको लिख सकते हैं? argon 18. So that means उसके बाद जो आपके 3 shells है, यानी argon के जो 3, that is 2, पहले शेल में 2 इलेक्ट्रॉन, नेक्स्ट में 8, that is 10, और तीसरे में 8, that is 18. This is how argon is represented basically. Now after that, if we talk about the general electronic configuration of 3D series, it is argon 18. Now this is very important, you can remember this. Argon 18 electrons, 3D 1 to 10. That means when you move from scandium to zinc, the total number of electrons, the d orbitals, they can be from 1 to 10. And also 4s orbital जो है, it can contain 1 electron or maximum of 2. So this is the general electronic configuration of 3D series. So this was all about the basics of the 3D transition series electronic configuration, its anomalous behavior exceptions and the reasons for the exceptions. I hope I have summed up the complete information as far as your theory class, as per your competitive exams is concerned. So this is all for today. The next time we'll come up with another important property about the 3D transition series, and that also will be to the point. So this is all what we have. So now if you want to further read this to the point lecture, so you can look at this, you can download this note here. We have this free PDF link. You can download this note, you can use it for the exam purpose. So this is all from the, thank you.